ready. Let me get my screen share here. That'll be this one. There we go. So we covered a lot yesterday. I want to do a bit of recap and overview, and then we'll pick up where we left off with lists and loops. So let's start with recap. I want to see how, let's do a quick 1 to 3. One to three for functions. Okay, threes, couple twos. I'm gonna get everybody in there. Make sure you put in there. How are you feeling about functions? 1 through 3. Okay, seems like we've got, my guess is we're averaging like 2.7 or something. 2s and 3s. Great. Okay. We haven't covered lists all together, but like, let's do this for lists. Let's see. I'll put a few things that we've covered in here for creating empty lists. 1 second. Creating empty lists. Append. And let's say what else did we cover? Yeah, we'll just do these two things. So we talked about creating empty lists and using append to add elements. How are people feeling about those two things? 1 to 3. Okay. Lower on this one. Okay, great. All right, thank you. We'll cover that a little bit as well. All right, so I'll just do the overview real quick. Learning Python, we've got to know data types. We've got to know abstractions. We've got to know control flow. We've got to know iteration. So we know a little bit, we've covered a little bit in each of these categories. The data types we've covered: int, float, bool, string, none. We covered lists as well. Abstractions, we've covered variables, functions recently. Control flow, control flow, we've got 3 conditional keywords: if, elif, else, right? And using these in different combinations gives us different unique sort of logical scenarios. We've also got some Boolean operators, less than, equal, greater than, less than, equal, greater than, equal. I don't know why I'm doing this in this order. less than. We've got not equal, equal, not equal, less than, greater than, less than or equal, greater than or equal. We've also got not and or, and these are more for helping us constructing conditions. There are other ways to construct conditions that don't necessarily use these, but this is really common to construct conditions with one or some of those. Iteration, we've talked about for loops. We're going to talk about more about that today, and eventually we'll get into while loops, but we're going to be covering for loops. So for today's topics, we're going to be focusing on loops and lists. Hopefully you can see how they go together. Oh, I forgot to ask. Let's do one for for loops real quick. So for for loops, how you feeling? 1 to 3 on for loops. I'm expecting lower numbers on this because we haven't really gone too deep into it, so no worries. Okay, this is kind of more what I'm expecting. Great. Go ahead and get in your answers. Okay, I'm going to give some similar examples for a recap to what I talked about yesterday. Try to be just real brief with it, kind of run over what we went over yesterday in the same way, and then we're going to pick up with the material and continue. So we want to actually, I want to recap lists and for loops. So let's just look at creating a simple list. I'm going to call this, I'm going to save it in a variable. I'm going to call the variable list. I'm going to spell it LST. The reason I don't use LIST is list, LIST is a built-in function, and even though Python will let me overwrite it, I shouldn't overwrite it. So we'll call it list instead, LST. So list equals empty list. Print list. No big surprises here. Oops, except that nodemon isn't running. So there is an empty list. I can initialize this list as empty. The first time we create a variable of any kind, we say we're initializing that variable. So I would say I'm initializing an empty list here, or I could initialize a list that's populated with some elements. Elements are what we call the things in the list. They might be numbers, they might be strings. We don't necessarily know their types, so we wouldn't say the numbers in the list or the strings. If we want to be generic, we'll just say elements, and that'll describe the things that are in the list. So we could just put some things in it, initialize it with some stuff in it, like that. Either way, whether there's stuff in it or not, I can add things to it with the list.append. Hello. I can append whatever I want. Let's just do 4, 3. So I'm printing after initializing, and I'm printing after each append, so we can see how it changes. So append is pretty straightforward. It just adds an element, it appends an element to the right-hand side of the list. You can see it's being appended to the right-hand side. So we're adding in a new element at the end every single time. So let's see. That's just creating an empty list and appending. And we can use append in all sorts of different scenarios to just add something to the end of a list. Let's do another scenario here. Let's say this. I'll do this. More recap. Put that out. Okay. So let's look at loops a little bit. So if I have a list, I'll just call this nums, which will be a list of numbers. It's really common that you have a list of things that you want to, and you want to do something with every individual element in the list. So we can iterate through a list, loop through a list, traverse a list with a for loop. We can say for I in range. Excuse me. I'm not gonna do range. I'll do nums. So I is a convention. If you're not sure what to call your identifier, don't think about it too much. Just call it I or something. I could call this num for num and nums. Print num. Okay, so we can print each number, right? I now have access to a variable that gets assigned and reassigned to each one of these elements in the list individually. That way I don't have to go access it individually. So if I did want to access it individually, we'll kind of let's build our way up to this for loop. I could say print nums sub 0. So using this syntax, putting the square brackets after the name, after the variable that holds the list. Using that syntax, I put the square brackets behind it, and then I put a number inside the square brackets, and the number corresponds, this number is called an index, and it'll correspond to some element in the list. And let's be a little bit something. I'm just gonna copy some. Let's be a little bit different here. Oops. Instead of numbers here, because if we have if we're using numbers for the indices, which we have to use numbers for the indices, I don't want you to get confused with the numbers that are being used as the indices, and if the elements are numbers too, I don't want that to get confused. So okay, that'll work. Here we go. So now I have a list of words. So why don't I just print that off now? Print. It's hardly worth calling nums though now at this point. Here, let me do this. I'll leave that with the for loop example. Let's call this words. So words list, let's print off words, and then so we can see the whole thing, and then I can access each word individually like this. So this expresses the element located at this index, right? So if I ask for words sub 2, that's going to give me the second index, which is actually the third element, right? So index 2 gives me 0, 1, 2, so it gives me these. You can see we get these there. So index 0 holds the first element, index 1 holds the second element, etc. So it's a little bit weird. You have to learn to count starting from 0, and it can kind of throw you off. But just if you remember that Python uses what's called zero-based indexing for its list, that just means that the list starts, the first index is 0. So yeah. All right. We can also use indices to get elements. So this will get elements if we're counting from left to right, but it's also useful to be able to like get the last element. Maybe you don't know how long the list is, right? You want the last element maybe in a list of 3 items or in a list of 1,000 items. So you don't know whether to say index 2 or index 999. So you can get the last element by using negative numbers. So if I do, I'll just reuse these. Oops. So if I do -1, that's going to give me the very last element. That'll be no. So who's and no. If I do -2, that'll give me the second to last element, right? So we're counting essentially from right to left, starting at -1, -2, etc. No I. Cool. What happens if I ask for an element that is beyond the last element? So let's see how many indices, what our highest index is. So we've got index 0, 1, 2, 3, 4, 5, 6, 7. So index 7 should be no. So if I ask for index 8, and you can kind of think through this, what would be the element that we would expect, or what would the expected behavior be? Does -0 mean anything? No. We'll try that out, but -0 doesn't actually mean anything. Yep. So this is going to be, if I ask for index 8, that's going to be out of range. So that's a index out of range. And let's do another one. Let's ask for, let's just look at -0. So I guess 0 and -0 are going to be both the first element in either case. But yeah, so I guess -0 works. It doesn't give you an error, but it's the same as 0. Let's do another one. Let's go for -7. It's going to be woods. -8 is going to be whose. -9 is going to be list index out of range. So that's actually the same error as going too far the other way, right? So whether we go too far from right to left or too far from left to right, we get an index out of range. Somebody's saying technically 0 doesn't mean anything, right? Well, so index 0 is meaningful. It gives us the first element in the list. So that's what I would, when I think, is it meaningful or does it mean anything? That's what I would say in this context. And it happens that -0 happens to be the same as using 0. So in terms of, say, abstract algebra, aka the absence of a number, well, I mean, I guess it means it's the value of represents the quanta of 0 of not having some other thing. So I think there's a joke being stated here that I'm not perhaps getting, but I'm gonna go with it. So sure, 0 means nothing, if that's where you want to take this. Okay. Cool. So that's how we can use indices to access elements, right? And this is how we can use a for loop to access all of the elements individually. So yeah. Actually, I'll put this one, excuse me, put this one up here. This is recap too. Oops. Cool. So this is covering creating a list, either empty or with things in it initially, and then appending to it, so adding things into it. This is covering looping through a list with stuff in it, with elements in it. This is covering accessing elements within a list via indices. So creating and appending, looping through, accessing individual elements. Are there any questions about this so far? I want to give us a couple minutes because I know this is kind of at the edge of where people are at. If you've got some code, if you're curious what it would do, you can run it. You can, if it doesn't make sense, you can ask me why it does that, whatever. So we'll open up for questions. I'll just put a minute on the clock, minute or two, see how we feel. Sorry about that. My phone where I monitor Slack is having a problem here. Okay, so we've got a few questions, it looks like. You can access a list from indices from right to left. Also, yeah. So if you use negative numbers starting at -1, you'll start indexing from the right-hand side of the list through the left. You know, -1 is the last element. No matter how long the list is, -1 is the last element. -2 is the second to last. -3 is the third to last, etc. And that can actually be really useful to be able to access elements from the right-hand side. For num in nums and for num in range nums, what's the difference between those two? The second one will actually give an error the way you have it written. There's let's see. The for num in nums, I'll show you. Oops, I'll show you what these will do. So what's the difference between these two? I'll just put this up top. Let's print nums and print nums. Y is, oh, that is the same. Okay, so this range, oops, that's why. This is going to give us an error. It's going to say list object cannot be interpreted as an integer. And that's because range only takes integers as its argument. So this first one iterates directly through, oops, I'm printing nums. I don't want to print the whole list. I just want to print the elements. So this first one iterates directly through the elements. And we can't actually we can't take the range of a list because a range is defined by integers. So if we give range, this fits into what I was going to talk about next. If we give range 10, it's going to create a range from 0 through 9. All right, so if I for num in range 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But if I do len, I can get the length of the list. Len returns an integer, so I can do len nums, and then that will define this range based on the length of the nums. So if I want to do a range that's equal to the length of a list, I have to use the length function like this, and that'll give me 5, like that. 0, 1, 2, 3, 4, 5. So it's actually 6 elements. Cool. Let me know if that's helpful. Somebody's asking about the homework in from the syllabus and how it matches up with the material. So we've recently, I've mentioned this a couple times briefly, but we've recently made some significant changes to the way that the speed at which we deliver the Python material. We used to kind of intersperse, like at the beginning of class, it was like me and Tovio would just alternate days, and I would do Python and Tovio would do stats, and we decided that it would be better to establish a firm foundation in Python for people to go into the stats material with, since Tovio uses a lot of coding in their presentation of the stats material. And then we realized we needed to slow down the Python material. So that process has been going on through the last iteration and this iteration as well. So the homework at times doesn't totally reflect where we're at in class. The way I'm taking this is we're moving slowly through the material in class and probably doing recap of what the homeworks are. So the homeworks are probably having you work ahead. I do want to emphasize this: we don't have any requirement around you doing the homeworks. They're just the modules and learn. What I recommend really is to just go through the stuff and learn kind of linearly, just from the beginning through. Take it at your own pace. Spend the amount of time that you have on it. Feel free to reach out to me, Tovio, or other members of our team for help and support. We have mentoring. We have this class. We have study hall, other resources available for you. Feel free to ask questions in the this channel or in the basic prep channel as well, and give help to each other. We really want to encourage that. So the role of the homeworks is at this stage, more to kind of give you like some sense of like pace through the material. It's not necessarily where that pace is going to end up, and we've kind of got we're still feeling out how we're going to be presenting the Python material in premium prep. So if there's some disparity, that's kind of the way it is right now, and that'll be ameliorated in the future. So sorry if that's confusing, but yeah, that's the current state of affairs. So hope that helps. Cool. It looks like we got another question here. For num and num accesses. Oh, for num in. Okay. I'm gonna paste this in. I'm gonna be really picky about this. I don't want to roast you, but so when you say for num and num, I think what you mean is for num and nums. For num and nums accesses the values of num. The values, I would say, values within nums, which is a list. For num in range, this has to be len range. Whoop. Len range. For num in range gives an error because range can't take. Sorry. If you meant nums the list for range, this would give you an error. If num actually was a single number, then yeah, that would work. So what you want to do is len here. Otherwise, that would give you an error. So for num in range len nums accesses the integers from 0 to size num. Yep, that's len. Is this are you a C programmer? Perhaps? There's nothing wrong with that. But. So the integers from 0 to len nums minus 1. Cool. Hopefully that clarifies your question. Range nums. Yeah, there you go. Bingo. Great. We're going to be covering this material. We're going to be covering this, working with lists and loops a lot. It's really central. So don't worry, I'm going to move us forward. We're going to continue through the material. So yeah, thanks for the questions. Oh, you're a former C++ programmer. Okay, that makes sense. I was like, I'm seeing size, and I'm like, there's some C in there. I smell some C. C or C++. Okay, cool. Oh, somebody's asking, what is pass? Pass is valid code that doesn't do anything. That sounds really weird, but there are times when Python insists that you put some code somewhere. Otherwise, it'll be like, there's no code here, and there's supposed to be code here. So sometimes you want to just say like, yeah, there's no code there, Python. Don't worry about it. Don't freak out. Don't throw an error. Just pass. So pass just means um, it just means here's some valid code, but I don't need you to do anything. That's literally what it is. And I'll show you if you do if 3 equals 3, which of course it does, this is an error, right? It says unexpected EOF while parsing. It's a weird one because it's not actually pointing at this, but what it really wants to see, or let's just throw a print fin here. So what it really wants to see, it says indentation error, it expected an indented block. What it really wants to see is something inside of here. I could just throw a print or just some code or whatever. So if I don't want to do anything, I can just say, don't worry about it, Python. I'll come back to that later. And then that'll work. So that's what pass is. Cool. Good question. Okay. So let's move on from the range function. So we've already looked at range a little bit. So range is a function that you're going to use a lot. You're going to use it mostly in this portion, in the iterable portion of writing for loops. When you write a for loop, often you'll be iterating through a range. Sometimes it's a range of the length of a list or a range of something. Sometimes you just need to repeat something 7 times, so you do for blank and range 7. So range is a really useful one, and usually that's where you'll see it. So range takes whenever. Okay, I want you to write this part down. IPO. Yeah. Whenever you learn a new function, you want to take note of. I'll just constrain this down to. Oh, how about this? ION. Ion. That's easy to remember. Let's do it like this. So you want to know what its inputs are, outputs, and then like any other notes, we'll do it like this, notes. Wrote none. So inputs with an N. Okay. Inputs, outputs, and notes. And notes are just like, what does this thing do? Does it have any side effects? Under notes, I would put like append, for example, mutates a list, right? That's not an output. That's not an output in the sense that I'm using it here. It's not what, like, append doesn't return the list with the thing appended on it. What it does is alter the list you call it on. It changes the list you call it on. There's other methods like that. So any mutable method might take note that it's mutable, or a description of it, right? So with this one, let's do this. Let's say so for range, let's say for range, generates a range of numbers defined by its inputs. Okay, so that's a little generic, but you could be more specific than that, but I don't know, that's good enough for me. These are just your own notes about it. Just make sure it's descriptive and, like, gives you a sense of what it's supposed to do. You can do this for functions that you're writing as well as functions that you're learning. So anytime I introduce a new function, I'm going to kind of try to cover these things, inputs and outputs especially, and give you a description of what it does. So inputs. The inputs are, let's take a note on it. Takes 1, 2, or 3 inputs. So it's a little funky. So I'll make 3 categories. So for one input, if we give one input to range, it's what's called stop. So we're passing the stop parameter. So stop is an integer. And it defines the upper stopping bound, the upper stopping bound of the range, right? So a range is just numbers in order, right? If we pass one input, it tells the range where to stop, and implicitly, I'll say this, for one input, range implicitly starts at 0 for one input, right? So for 2 inputs, it'll take the stop second, and it'll take the start first. So it takes start, then stop. So start defines the lower the starting bound of the range. Let's take a note on stop real quick, because there's something we should know about stop. Stop, the actual stop value passed is not included in the range generated. The range goes up to, but not including the stop. Okay, and we'll kind of look at an example of that. Cool. So if I takes 3 parameters, start, stop, step, also an integer, defines the interval that numbers will be chosen. The interval, the step with which numbers will be added to the range. Oops, and that's 3. Okay. So range's input rules are a little funky. And I think it's about as bad as it gets, at least for Python functions. And if this looks intimidating, don't worry, I'll show you examples. It's actually not that bad in practice. So hope that doesn't look intimidating. Okay, so outputs, it actually outputs as its own type. It doesn't return a list or a tuple or anything. Its output is literally a range. It's its own type. So its output is a range, a generated range of numbers from start to stop. I'll say EX for exclusive. Stop, since stop is excluded, right? So from start to stop exclusive in steps of step. Why don't I I'll put backticks around these so it's clear that I mean that these are code. Cool. So anytime you learn a new function, you don't have to be as thorough, or you can be, I was really thorough about the inputs here. You could lay that information out in a different way. You can be more or less thorough in the notes or the outputs, whatever. But just make sure you can write it down or not, or just keep track of it in your head. Just make sure you have a clear sense of inputs, outputs, and notes or some description, anything else you might want to know about it. Sometimes there's, nothing else. Sometimes it's clear what something does based on its inputs and outputs, but just, any additional things you might want to know from there. Some functions don't have outputs, some functions don't have inputs, and you can just take notes. Well, if it doesn't have outputs, why is it useful? There's probably some other description for why it's useful. If it doesn't have inputs, why is it useful? There's probably some other note that you could take about why it's useful. Okay, cool. So let's actually look at range. So the range function helps us create something like a list of contiguous integers, continuous integers. Range takes start, stop, and step in that order. If we only give one argument, it's treated as stop. The start is assumed to be 0. The step is assumed to be steps of +1. Start is inclusive. Stop is not. Stop is exclusive. Range is not an object. Range is an object that can help us iterate over a series of numbers. Can provide indices for items in a list or in a pair of lists. That's a weird way to put that. Okay. List indexing. This is what we covered before. More properly called, everybody calls it indexing. The correct term for this is subscripting. You'd be understood if you say indexing. Like I said, everybody calls it indexing. It's like it's one of those things where everybody knows it's wrong, but we call it indexing because we know what that means. So officially it's called subscripting though. So we can use indices to find elements at certain locations described by the indices, right? So we can think about the indices as describing a given location with indexing. Cool. Actually didn't mean to get into that. I want to show some more examples of range. Cool. So let's just play around with range a little bit. I'm going to do for I in range. So range's inputs, and I know I said this before, range's inputs have to be integers. I want to stress this because it's such an easy mistake to make. You have a string or a list, and it's fine. I mean, it's not bad to make mistakes. It's not, I mean, I make mistakes all the time. I get all the errors all the time, and that's a paradigm, like just run your code, get the errors, it's fine. It helps you solve problems quickly if you have that attitude. But it's also good to be thorough and have deliberate, distinct understandings of your code. So if you're writing a for loop and you're running a range and you're getting an error or something, you might want to check that, make sure that you didn't mean to do range len. That's a really common thing. If you want the indices of a list or a string or a tuple or something else, you'll want to take the length of it. That way you pass that to range, and then that's an integer, and range can handle an integer. So if I want to do range 5, let's do range 5. That's 0, 1, 2, 3, 4. So you can see, oops, you can see that this iterates over zero, then 1, then 2, then 3, then 4, right? So when I pass one number, this defines the upper bound of the range, the stopping point of the range, and it's not included. But notice, range 5 gives me 1, 2, 3, 4, 5 iterations. So it does give me 5 iterations. It gives me whatever number I put here. If I do 347, it's going to give me exactly 347 iterations, but it's only going to go up to 346. And it started at 0, even though that's not shown here. So I see some people, if you want your range to include your upper bound, you literally just add 1 to it. So plus 1, right? So if I have n equals, let's say 5, we'll do n plus 1. Of course, I could just set n to 6, right? But it's common that you're passing in a variable, and that variable is whatever it is, so you can just pass in that variable plus 1 more than that variable, and that will include it, right? If you want it to start at 1, you do 1 to n plus 1. That's going to be, oops, 1, 2, 3, 4, 5. Cool. So let me do this. I'll label these 1 argument, 2 arguments, 3 arguments. So let's do 1. So let's say I just wanted odd numbers for whatever reason. I'll start at 1 because 1 is an odd number, and we'll go in steps of 2. So we'll do, let's do n is 20. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Cool. So that gives you some examples of how you can use the start, stop, and step parameters together. All right. Any questions about range? Start, stop, and step. Oh, sorry, I didn't realize this was a question. Was there a reason why stop value has 99 plus 1 and not 100? Cool. I think maybe that got answered. I think that's good. Range only works with ints, right? Yes, that is correct. Only integers. Yeah, that reminded me. I did want to show this with floats. Shows you what happen. I'll show you what happens when you try to use a float. So let's try to do that. So if I do for I in range, I'll just do range n equals 4.0, right? So if n equals 4, print I, this is going to be fine. 0, 1, 2, 3, no big deal. So if 4.0, that's going to be an error. Oops. So it says type error, float object can't be interpreted as an integer. And even though it could, even though this value is sensible, if you think about, like, if you designed Python the range function to just work with a float value that technically would work, where the value would work, if this was like inside of a function or something, you were handing a float to that function, that float was being passed to a range, you know, you're kind of signing off on it being okay to pass a float, any float, right? So what would it even mean? Like, what is range 4.3? Like, how do you even make a range like that? Do you like take the smallest or like the largest? Yeah, see, I don't even like, I'm like thinking, what do you take some increment that fits into 4.3, but how many times? It's not 4 times, you know. Should it iterate through 4.3 times? What does that 0.3 iteration look like, you know? So you know, I don't know what to do with that. So the result is a lot of floats just don't even make sense to give to a range, and the ones that do, range is still like, no, that has to be an integer. So we can fix this by casting it as an int if we wanted to. So even if this is 4.3, this is going to work. If we cast it as an integer. Cool. If you want to include, good discussion here. Is there valid notation for stop step, or is it mandatory to indicate start, stop, and step? Well, the range, think about it like this. Some value is given for all 3 of those. It has to be. It's just whether it's like, if you don't supply one, it will assume one. But it can't not, like, the range has to start somewhere, right? If you want it to, so let's break it down like this. Start, if you don't pass a value for start, it defaults to 0. So it starts at 0. Step, well, there are sort of 3 input patterns, right? Where we supply 1 input, 2 inputs, or 3 inputs, and in all 3 of those cases, we're supplying something for step. So there isn't a default for, or excuse me, not step. Oh gosh, stop. That's what I meant to say. There isn't a default for stop. So stop is always supplied. So stop is always supplied by you, right? So we can't do like range with nothing passed to it. That would be range like this is going to be an error. So it says type error, range expected 1 argument got 0. So can't do that. Step, if you think about it, right? Like if I wanted every other number, I'd do step 2. If I wanted every 5th number, I'd do step of 5. If I wanted every number, what step would I do? If I want every number between, you know, if let's say I do range 9 or range 10, that gives me every number between 0 and 9 inclusive. What step describes that? And I'll leave it to you. Put it in Slack. What step would give you every single one? Yeah, exactly. Step equals 1. So step defaults to 1, right? So every time you generate a range, and this is true of any function, some functions have defaulted, we talked a little bit about default arguments. That's essentially, I'm not sure if that's how range is built. I think there's another trick being employed here, but yeah, I think there's another trick being employed here, but essentially there are other functions that take default arguments that kind of have this behavior um, of defaults, right? Where if you don't supply something, it will assume a default, right? So what the reason for that is when you write a function, that function is reliant on those values being supplied. There's no scenario where it really makes sense to just have a value that is sometimes there and sometimes not. There is sense in having it assumed in certain scenarios. So those values get supplied one way or the other. If you don't put them in, it will assume something. So to answer your question, is there a way to do, since one input gives us stop, 2 inputs gives us start and stop, 3 inputs gives us start, stop, and step. The question was, how do you supply stop and step? It's the same as saying range 0, and then your stop and step values, right? So you know, if you wanted stop of 20 and a step of 3, you could do that. Yeah, so you just use, knowing that it defaults, you just plug in whatever it defaults to. Yep. I don't know if you can do, I've never tried to do keyword arguments. What if we did step equals 3, stop equals 20, and start gets 0. I don't know if this is going to be valid. Range takes no keyword arguments. Okay, so we can't And that actually kind of confirms how I thought it was written. Yeah, so interesting. So that doesn't even work. We can't use keyword arguments, which is fine. Pay no attention to keyword arguments. We're not gonna, it's not really something that really does anything that you need. Okay. Cool. We're this is prime time for a nice intermission. Let's take 5. Let's reconvene at 15 after the hour. Oh. All right. And we're back. Go ahead and get seated. Get ready. Turn your cameras back on if you don't mind. If you do mind, no big deal. Cool. All right, good. List membership. So this is something you can do with lists and other collection types as well. You can test for membership. So you can see if some object is a member is inside of a list. So let's call this num. We'll say num is 5 and list is it's a list. Okay, and then let's just print this off. And this is a true or false expression, so we could even include this up with our kind of Boolean related tools here, in. And we'll say in shows up in a few different contexts. So it's a conditional, it's a keyword that has, it's a contextual keyword. So in for test or membership. A lot of times you'll use in a condition for control flow in order to say if something is a member of a certain list, you'll want to perform some certain action. So we'll say print num in list. Right, so this expression num in list, it's kind of like a question. It's like, is num in list? True, num is in list. Let's say no 47. False. Right, 47 is not in the list, right? Let's just do that. Okay, so is 4 in the list? False. Is 5 in the list? True. Great. Forgot about that. We can also check the inverse by putting a not here. Like that. And I think that's the same. I think, can we do this? Yeah, so this is the same. Generally, convention is 5 not in list, so it's nice that you can write it out really semantically like that. Oops. Cool. So sometimes this is called a check for membership. Sometimes this is called a check for absence. It's the same mechanism. It's just when you're doing the negative case, sometimes I'll call it a check for absence. We'll check if something is absent. True or false. Is 4 absent from list? True. Is 5 absent from list? False. That kind of thing. All right, slicing. So slicing. So remember start and stop and step with range. We have a similar mechanism that relates to using indices from lists. So let's say I take my list here, my trusty old list, and let me get my word list. is it? Here it is. Oh, wait. Okay. So words. So one thing that I can do with lists is slice them, and what slicing means is being able to get a sub list, right? So let's say I wanted a list with just these elements in it, right? A list with just these ones, right? So this sublist starts at index 1 and goes through 2, 3, 4, goes through index 4. Right, so that's my goal. So I'll say sublist equals, we don't need to comment that out. Sublist equals, so what I want to do is create a list that's like this by slicing the words list. So what I can do is I can say words sub, we'll slice from 1 to 4. So I'll show you what's going to happen. Print. Okay. Oh. Sublist. Copy paste. Output. Go. So notice I didn't quite get there. Right? So this is a really similar thing to ranges start, stop, and step. In fact, we usually just call this start, stop, and step because that's what it is. So this first part, when I do a slice, I start off like I'm going to do an index, right? And then I put in, you can do it with 1 colon or 2. I always put in both colons, but I'll show you, you can do it with either. So I get to tell in this first, when I put in the colons, it creates these 3 sections, right? So in the first section, they're like partitions that kind of partition this off, right? In this first section, whatever integer I put here is going to be an index that represents the index that I want to start at, right? So if I want to start at index 1, I say 1. If I want to go up to wherever I want to stop is specified in the middle here, right? This tells it what I want to go up to. And just like in range, the stop is excluded. So if I want to go to index 4, I have to do 4 plus 1, right? Somebody was asking about this with this question about like, why does it say 99 plus 1? Why not just say 100, right? The plus 1, it like, to be clear, this and this, like 4 plus 1 is 5. The reason I would write it as 4 plus 1 is I'm declaring my intent that I want to go up to 4, but I want to include it. So it's just it's sort of a declaration of intent, like, yes, I meant to include this, or not, rather than going up to 5 and not including it or whatever. So to me, that just makes it clear what I was intending to do. And in this case, in the third partition, or in the third section, that's the interval, the step, right? So we could do every second element starting from index 1 going up to index 4 plus 1, right? And that would give us woods and R. So if I do that, woods and R. We don't need a step interval there. We can just do that, and that'll give me that slice. So words sub 1 colon 4 inclusive colon. So I'm weird in that, like, anytime I do a slice, I put in both colons. But if you just intend to use start and step, start and stop, you don't have to put in the second colon. It's exactly the same to just leave off that second colon. But I always do both because I like it that way, but you can make whatever decision around that you want. Cool. Any questions on slicing? Let's do a quick 1 to 3 on slicing. Good. Okay. Oh. I was expecting lower numbers. Interesting. All right. Good. Okay. I'm seeing mostly. I really struggle with indices, and this is very much helpful. Okay, good. Good to hear. Okay, so mostly 3s. You got some 2s. I see a 1.5 in there. Okay. So I just wanted to get a sense. So yeah, so we will be revisiting this concept with other things, so you'll get plenty of practice. If anybody is like a 1 in something, if you're like really struggling with something, you feel like you can't move forward because of that, feel free to DM me. We'll find a time. Either you can meet with me or somebody else on the team, and we can work one-on-one. I think a lot of people think they're gonna like bother me or take up a lot of my time if they ask for help in that way. I've got this next week pretty wide open though. Generally, my schedule has at least some availability, and that's true for most of us on this team. So, yeah, don't be shy. Okay. Nested lists. These are lists that contain other lists. So let's say list O lists is going to be a list of lists. Okay. So here I have a list of lists. So let's just print it off. List of lists. I can slice into this, or excuse me, I could slice into it, but I'll index. Let's say I want to index into this so that I get this B here. So I can index into this list at index 1, and that'll give me that ABC list. And then this whole thing, including the indexing, what is this? What I have selected, what is that? What does that evaluate to? Go ahead and put it in Slack. We have a question here. Is there a default? Is there the default values like range? Oh, I'm sorry. I spaced that. Yes. When slicing, um, there's the same default assumptions. So if I leave out the start, it'll assume that I wanted to start at the beginning. If I leave off the stop, which I can actually do, it'll assume I wanted to go to the end. And if I leave off the step, it'll assume I wanted to take steps of +1. So, gosh, I totally forgot to mention that. Thank you. Okay, cool. So, yes, somebody said a list. That's the answer I'm looking for. So, and some people gave the example of the list, which is not incorrect as well. So, this is a list, and I can index into list. So if I want to get at this B right here, I can do sub 1, and that'll give me that B. If I wanted to get that C right there, I do sub 2. So this is lists sub 1 sub 2. That'll give me that C. One thing that's a little bit weird about lists inside of lists is I can append to the list inside the list by doing list sub 1 dot append. Let's just hello, and we'll do this sub 1, print off the whole thing, and then just the one we appended to, right? Let's print off the beginning one, and then the one we're appending to. Okay. Okay, so here's the before, and here's the after. So I can append list sub 1 is a list, and I can append to it. So even though it's inside another list, if I can access it, the syntax that I would use to print it out to access it, I can just treat that as the list, as the name of the list. So the name of this list, the name of it is lists sub 1. Of course, I could give it another name. I could say ABC list equals list of lists sub 1. And then let's print ABC list. See, it's the same thing. Of course, I can append to ABC list. Just like that. Now I have a name for it if I wanted. In general, you will want to avoid giving a single list multiple names. It can make things confusing. But it is possible. Cool. All right, let's do this breakout. Let's see if I can get this like that. And, oh, you know what? Why don't I go, huh. That's not even gonna find it for me, is it? Is this number 5? Sure is. Okay. Oops. Not that one. This one. Okay, sorry about that. I'll paste that in. Oh, and it's just totally unformatted. Oh, that's better. Okay, sorry. Just playing with Slack's kind of funky formatting rules here. Okay. There we go. I'll put 4 minutes on the clock and go ahead. Okay, we got a few. Give a little more time for this one. We'll do another minute. Okay, go ahead and get in your final answers. I'm going to go through these. So index in here to get 6. So first of all, I'm just going to do a print to numList just up here. I know I've got a bunch of them. Just comment those out for now. Oh, great. Of course, I changed the name. Okay, so 4, 5, 6, so that's 0, 1, 2. So to get 6, we'll do sub 2. To get 15, we'll do, well, I mean, there's technically 2 ways to do both of these, but there's, let's do -1. Since we're doing range 16, 16 is not included, so -1 kind of makes sense to me. And the sublist 10 through 15. So we'll slice starting from 4, 5, 6, 7, 8, 9, 10. That'll be 6. And for this one, I will use the defaults. We want it to go all the way to the end, so I won't tell it anything here. We want it to take steps of +1, so I'll do that. So that's 10 through 15. Slice numList to get the sublist 4, 6, 8, 10, 4, 6, 8, 10, 12, 14. Okay, that'll be a similar thing here. So 4 is going to be the beginning. So I think it would just, if we do steps of 2, yeah, 4 through 14 in steps of 2. Yeah, that's great. So we didn't need to tell it where to stop. It just stopped early because 15 was not part of that. And then finally, 8, 7, 6, 5, 4. Okay. So 8, 7, 6, 5, 4. We want to slice. We can do steps of -1. And we want to start at, if I start at 2, 3, we want 8, so I think I want 4. 8, 7, 6, 5, 4. Yep, 8, 7, 6, 5, 4. So we'll start at 1, go through -1. Okay, that's good. Another thing I could do is I could start at 4 and go up to 8, which is going to be 4, 5, 6, 7, 8. That'll be index 4. Right, like I said, 5. And then I could subscript into this list or slice into this list with -1 there, and that's another way I could do it. Just for fun. Okay, cool. Immutability, we've touched on this concept. We haven't covered it too deeply. So let's start talking about mutability. So lists are our first mutable type. You'll notice, like when I lay out the data types, I'm going to do all the mutable types in this group below lists here. And I always put a space here to kind of keep them separate because it's important for me to categorize the non-mutables and the mutables apart from each other, because that's really important information to know about a data type. Is this data type mutable or not? And that's going to tell me kind of what I can, how do I put this? It's going to tell me how and when I may anticipate changes in the value, right? So a mutable type is capable of changing on the data type level, on the list level, right? So let's look at this. Let's have a list equals a list. So list dot append hello. So I'm going to show you a function called ID. So notice these two IDs, and it's a big long number, but they are the same number. And I can tell because if you look at the right-hand side, that's likely where it's going to change. So an ID is a number, a unique number that is given to every object in your Python program. The interpreter goes around and gives everything an ID. Right? So if I have this number here, print ID num. Okay. Let's say if I do num plus gets, let's just do another 10, why not? And then I print the ID of num, what's your expectation? Is the ID going to be the same or is it going to be different? I know I didn't cover this yet, but this is just me asking you to think through it, right? Like, just think through it. What do you think is going to happen? Same or different? Same. Same? There are a lot of people saying it's the same. Same ID. Okay. Different. We got some difference. Couple for different. It's interesting. It's pretty even split. For somebody who, let's see, why do you think, if you think it's going to be the same or different, whatever, why do you think that? Feel free to offer an explanation. You're changing the list value. So this is a number. There's no list here. We're working with a number. Real quick. Let's just be clear. This is a number, 10, print the ID of the number, the value, add 10 to the number, reassign it, print the ID and the number. So we're just seeing, so we're juxtaposing this behavior against this behavior, and I'm just testing your intuition. Okay. Altering the num, therefore we'll have a different ID. Content doesn't change the ID. Same because the ID is identifying only the num, not the num plus something. Interesting. Okay, cool. So let's run this. So these IDs are different. Every time I run this, everything will have different IDs. So if I run this again, both of these IDs are going to change, but, just suffice it to say, the IDs are different. And the reason for this is, when I add two numbers together, when I add two numbers together, adding A and B together does not change A or B, right? Is that intuitive? You know, if I did this operation, C equals A plus B, C equals 8, and if for some reason, like doing this operation just changed A to 8, right? That wouldn't be good. That'd be pretty bad. Nobody would be working in a, well, actually, people would be working in a language that did that, because it would be difficult, and there's like people that like to work in intentionally difficult languages, but it's not the case, right? So let's print A, B, and C. A, B, and C. It's not a big surprise. So what this kind of operation is, this is sometimes what we'll call a transform rather than a mutation. Those words kind of sound the same, but we ascribe specific meanings to those. So a transform in this context, somebody's saying that would break math. Yeah, that totally would break math. It would be awful. Yeah. So what a transform is in this case is it gives you you think about it like a different version of it. It's it doesn't cause a change to any of the inputs or anything in the system. It just gives you back the version of A and B where A and B are added together according to the operation that I chose, which is addition, right? So A plus B is 8. And that 8 is rendered or expressed separately from A and B. So this tells you, if I do something like A plus equals 3, this might look like I just broke the rule that I just stated before, right? It might look like I'm like violating that somehow, because we know if I print A will be a different number, right? But let's do something like this. Let's say Z equals A. We'll just do this. Actually, let me back up a little bit here. Let's not get this example all caught up with the next example here. Let's do a different example. Okay, we'll just make a new section. Let's make a new section here. So let's say A equals 10. And let's print ID of A and A. And then let's say A plus gets 1. And we'll do the same thing. So we'll see a different ID. Remember, this gets rewritten as A equals A plus 1, right? So that's that familiar thing. This is going to express a different number. And that different number is just going to be reassigned and recaptured into the variable name that held the previous number, right? So what we did, this is reassigning the pointer according to a value that, relative to a value that it had before. This isn't altering the integer, it's altering the pointer to that integer, right? And we can kind of prove this if I do Z equals A, and then let's do the ID of Z, and we'll see that the ID of Z is identical to when A and Z had the same value, and then when we change A, Z's ID is still what it always has been. Oops. change that to z. There we go. It's ID and its value, actually. So this describes an immutable process. And I'm explaining this like this is a lesson about lists. Why am I talking about numbers? But I'm explaining this to juxtapose an immutable behavior against a mutable behavior, right? So in this case, I'm not doing that plus equals. I'm using a special tool called Append, right? And Append has agency, has the ability to mutate the list that it's called on, right? So list.append hello mutates the list. It changes the value of the list. So since it changes the value of the list, the ID stays the same. It's one list, we just changed it. So this is a different kind of behavior than, say, an integer, where any change we make to an integer isn't really a change to the integer. It's a change to the pointer, the identifier, the variable that references that integer. That's it. So we have agency to move that variable to point at different things, and we can emulate something that kind of approximates mutation, but it's not mutation, because in the examples with integers and with other immutable objects, what we're doing is we're getting a different version and maybe reassigning that version, different version, to a variable name, in which case we delete it. Or excuse me, in which case we just reassign the variable and to a different number rather than changing the number. In this case, we are changing the list, but it stays the same list. Okay. In what context is the ID function useful? For demonstrating what mutability is. That's mostly the time that so if you tell your friends, oh, I'm learning Python, they're like, oh, that's cool, I've always wanted to learn the code, and you want to say like, oh, here, let me teach you about mutability, then you can use the ID function. That's the times when I've used ID. I think there are other uses for it in terms of like getting into, if you want to see if two objects literally are the same object, you can check equality of the IDs, and there's actually a shorter way to do that using is, but I don't find myself using the ID function that much outside of teaching and saying, hey, this is what mutability is all about. So is using the final result / value in the calculation to determine the so Python is using the final result / value in the calculation to determine the ID. As long as the result is the same, doesn't matter how we arrived at that result, the IDs should match. I'm not sure if that's a question for me. I'm not totally following that one. Sorry about that. Cool. We got through a lot. I'm gonna wrap up here. If that question is still standing, hang tight for a second. We'll open up for questions and I'll start uploading the video. We got through a lot. We got to get through really just copy is the major thing. We'll touch on unpacking next time, but so we'll have a note on copy next time, and that relates to mutability. We'll kind of run down mutability again. It's a bit of a dense concept, so don't worry if you haven't fully grasped it yet. It'll make sense soon. So let me get the recordings stopped. open up for questions.